Hello students, this is Bharat Bhanji here. In class 11 physics, today we are going to learn errors in measurement. Okay. So first of all, you should know that the measurement are very essential part of the physics. On the basis of measurement only we can verify the law, we can verify the different theories and we can get new ideas, and that is only because of the measurement. Okay. So the errors are also there in the physics. Okay, so it is better to know your errors. If you know your error, you can correct it properly and you get the accurate knowledge of the physics. Okay, so we can minimize the error by knowing its nature. Okay, so first of all, it is very important to know the different types of errors. Okay, one more thing is there, that is the precision and accuracy. Okay, suppose any measurement, suppose the length of this pen or this cap is about say 2.329. This is your actual correct length of this pen. This cap is 2.329 centimeter. Okay, if I want to measure this with your small scale, okay, so whatever this 15 centimeter scale we are using, if I use that scale to measure this, it may say it is measuring by normal scale, it is 2.3 centimeter. Okay, it is just showing 2.3 centimeter. And if I use a very high precise unit, suppose I use this micrometer screw gauge, which we are going to use in the which we are going to see in the physics lab. Okay, so if I use that, it may say something 2.218 something, okay, centimeter. So here we can say that here there are the only after decimal point there is only one place over there, and here we are having the three places. Okay, but this 2.3 is close to 2.329. So this way we can say that it is your accurate reading. Okay, it is close to the actual value. And when we can have under 2.218, it is far from 2.319, 3.329. Okay, so it is not accurate, but it is having the more number of digits. So that's why this is more precise. Okay, so this is your difference between precision and accuracy. Accuracy is the difference between the true value and measured value. It's called as accuracy. And precision means how much more places it is giving after the decimal point. Okay, that is your precision. Next is there are the different types of error. So mainly there are the two categories. First is systematic error and second is random errors. Okay, so first, in the systematic errors, that can go in one direction, means either it may be positive or negative, and if we subtract or add that particular value, this error can be minimized. Okay, so there are the three other parts of the systematic error. First we can say the instrumental error. Okay, first is instrumental error. Okay, now see here how the instrumental error can occur. Suppose we have the thermometer, okay, which is calibrated for your normal temperature, so which is giving the 1 degree, 2 degree, 3 degree and so on. Okay, so we can say the scale of the thermometer will be like this. It is 0 degree and it is 100 degree. Okay, so but because of some problem or because of wrong calibration, when the temperature is some 2 degree, it is showing 1.9 degree always, 1.9 degree Celsius always. Okay, so when the temperature is, when it showing the temperature of 100 degree Celsius, when it shows the temperature of 100 degree Celsius, it is actually how much? It is 100.1 degree Celsius, because 0.1 ka difference is there. Okay, whenever we have the thermometer which is roundly placed, so instead of 2 degree it is saying some 1.9 degree, instead of 0 degree it is saying some less than minus 0.1 degree, and so if it measured 100 degree, okay, it is actually the more than that. It should be actual temperature is 100.1 degree. Okay, so by adding 0.1 degree to whatever the measured temperature, we get the accurate value over here. Okay, so this way the instrumental error is there. Also, second example we can see, that is your scale. Okay, so your scale has a measurement of say 15 centimeter, and it is starting from this. 0 is starting from here, then we are having the small divisions, and like way we can have over here. Okay, now if any student by mistake does not consider this part, okay, यहाँ पे कुछ भी division नहीं है. If any student doesn't consider that and he measured as it is, okay, so he always gets the less value, and if you add this much value to that reading, you will get the correct reading, and all these such errors are called as instrumental errors. Second is imperfections in experimental techniques. Okay, now there are the human limits for the different things. Suppose when we are going to the doctor, if he want to measure our body temperature, what we take, he take the thermometer in your mouth or in the below the shoulder. Okay, that way they can measure the temperature. Okay, but they want the body temperature. Okay, so but temperature of the body is always higher than the outside the body. Okay, so that difference will always be there. Okay, so these are the imperfection, means we cannot do anything. There are the limitation of the human being. So all these errors are called as the imperfection in experimental techniques or procedures. Third are the personal errors. Okay, the errors caused by the humans that we can call as a personal errors. Okay, so first is the negligence, error due to the negligence. Okay, suppose we want to measure the oscillations of the pendulum. Okay, so pendulum can oscillate like this. Okay, so one oscillation is if it is starting from here and it oscillates over here, and if it is coming back over here, so this is your one oscillation. Okay, so if whenever in place of counting we are counting 1, 2, and if you miss something, okay, so if you are not considering the 4, so we measure 1, 2, 3, 5. Okay, so this way this can happen because of the negligence over there. So this error will be considered as a personal error. Okay, other thing we can say, whenever we are using the microscope to see the different things. Okay, so different person can have the different vision scale, so that way he may get the different readings for that. In the optics we can say we can see such problems over there. Also some might feel difficult to remove the parallax. Okay, so somebody have a habit to see like this by bending his head. Okay, so that time he cannot remove the parallax. Okay, so that all these errors which is occurred due to the human errors or human incapability or negligence, that we call as the personal errors. Okay, we can solve these errors by taking proper precautions. Okay, next important type is random errors. Okay, now we can remove the systematic error. So first, instrumental error, we can take the proper instrument, we can see its calibration properly. Okay, we have the proper procedure for any particular experiment. Next, we are following all the precautions, so there is no chance of personal errors. Still some error can occur in your experiment, or you cannot get the perfect results. Okay, so all that are possible that occurring because of the random errors. Okay, I think you did experiment of Ohm's law in class 10. Okay, so in that we are measuring the potential difference and electric current. Okay, but if there is a fluctuation in the electric power, okay, electric power ही fluctuate हुआ, so that time that error may occur in your experiment. So that error is called as your random error. Also, if you are doing some experiment related to the temperature, so we can see that in the morning time temperature is different, in the afternoon temperature is very high, and after that it is temperature slowly decreasing. Okay, so we get the 3 different results at the 3 different times. Okay, so this is also your error due to the random errors. We cannot have option for that. Also, sometimes when we are talking about the speed, okay, so sometimes the wind, to that wind also, direction of the wind or the speed of the wind, that also might affect your results. Okay, so all these are the factors which is not handled by us. Okay, so that errors are called as the random errors. Here we can see fluctuation of the power, rise or fall in temperature, changes in direction and speed of the wind, etc. That are the random errors. Third is least count error. Okay. Now, least count means first of all you should know what is the least count. We are having the measuring scale. Okay, so that scale is of 15 centimeter long. Okay, so maximum distance it can measure is 15 centimeter, but the minimum distance that we can measure through your normal scale is called as 1 mm. Okay, the minimum distance which we can measure is 1 mm or 0.1 centimeter. Okay, that much distance we can use. Okay, now for the more accuracy we can have the vernier caliper. Okay, remember the name. We are going to do the experiment with this in physics lab definitely. So that least count is 0.01 centimeter. Okay, if you want more accuracy, then we are going for the next device that is called as screw gauge or micrometer screw gauge. We can say here screw gauge or screw gauge sometimes. Okay, so it is your 0.001 centimeter least count. Okay, so this way we can have the different instrument. Now, how we can consider error in this, that we are going when we are looking for the sums, that time I will show you how we can consider the errors in the least count. Okay, now the accuracy level is highest for your screw gauge. Okay, screw gauge ka accuracy is most, then it is vernier caliper, then it is your normal scale. Okay, so according to your requirement we can choose a suitable device to minimize the error due to least count. Okay, to minimize the errors, the first thing you have to do is you have to take large number of readings for any particular experiment, and you need to follow some basic procedure. So when we are having the large number of readings, first you have to find the mean of that value. Okay, so that we can consider as a true value or actual value of the reading, mean or average we can say. Okay, now next is we can get the absolute error, relative error and percentage error on the basis of the mean value. Okay, so first suppose we are having the readings of any particular thing, that is A1, A2, so on up to AN, or n number of readings we are taken. Okay, so first thing you have to do is to find the mean value for that. So we can say that AM, that is the mean of all this, is equal to A1 plus A2 so on up to AN upon N. You know how to find average for this. Okay. Second thing you have to find is the absolute error. Now absolute error is the error in each reading. Okay, so what is the error in reading of the A1? What is the error in reading of A2? So that we can say it is a absolute error. So we can say that delta A1 is absolute error in A1. So we can show that here difference between AM and A1. Okay, so it is in mod. So you have to take this as always positive. Okay, if it is minus 0.3, then only you have to take it is 0.3 only. Okay, so you no need to consider negative sign over here because we are having the absolute value over here. Second thing, we have to find suppose error in A2, so we have to do AM minus A2. Okay, so this way we can find in n readings, for nth reading we can have mod of AM minus AM. Okay, so this way we can find absolute error in each reading. Okay. Third thing we have to find, that is a mean absolute error. So this absolute error in each individual reading. Okay, so if you take average of all this, that will be your mean absolute error. Okay, so we can denote this as delta AM, mean absolute error, is equal to delta A1 plus delta A2 so on up to delta AN by N. Okay, so mean of all absolute errors is called as mean absolute error. Next is relative error. Now relative error is the ratio of mean absolute error, that is delta AM, upon the mean value, that is AM. Okay, so ratio of the mean absolute error and the mean value is called as the relative error. Next is percentage error. So if you multiply relative error into 100, that will be your percentage error. So we can say here delta AM, that is mean absolute error, upon mean value into 100 will be your percentage error. Okay, so this is your simple method for error estimation. Okay, it is very simple calculation. You have to find mean, then subtract the every value from the mean, then take the mean of that, and upon that mean we get the relative error, and if you multiply it with 100 we are getting the relative error. Okay, sorry, percentage error. And here always you have to use rules of significant figures. Okay, you should see the NCERT example 2.7 on page number 25 of your NCERT. Okay, so if you see that example, you will get the idea how to find mean value, how to find absolute error, mean absolute error, relative error, and percentage error. Okay, and if you are not getting it, we are going to do in the online classes. Okay, next you have to give tests regularly, that is MCQ test. Okay, you should follow the worksheet on your, you should solve worksheet on your physics notebook, and you should attend both the classes which is given by me and also given by the Richa ma'am. Okay, thank you, all the best to you.